good afternoon, everyone. I'm Karl from the UP School of Economics, also with the GPDP, and it's my pleasure to present the findings of our study. Okay, so the study is entitled Mapping Natural Gas Demand in Batangas Manufacturing Special Economic Zones. And this is done with the team composed of Jacob Magadia, who's frantic over there on the right-hand side, Mel Lopez, who just presented this morning, Jess Alvinia, Tim Enares, and Dr. Raul Fabella. And this research is part of the GPDP project in partnership with the DOE, the AREA, and UPSC-RFI. And before I start my presentation, we would like to extend our heartfelt thanks to our partners from DOE, PEZA, and JERA that made this research possible. So the following are the objectives of our study. First, we aim to estimate the actual natural gas demand of manufacturing locators in Batangas SEZs. So this will give us a baseline for assessing whether a transition to natural gas is economically sound, especially for investors, operators, and policymakers looking at long-term energy planning. Second, we want to identify how much future capacity might be needed if natural gas were to be scaled up as a viable energy source in the region. This is especially important in the light of new infrastructure needed and regulatory developments. And finally, we want to conduct sensitivity analysis to test how these demand projections might change under different assumptions, such as price shifts or production growth. Next slide, please. So again, our focus is on Batangas, which I will reiterate the reasons for why we are focusing on Batangas. First, 5 out of 7 infrastructure projects, LNG infrastructure projects, are being developed in the province. So that means that Batangas is fast becoming the epicenter of LNG activity in the Philippines. Second, the area already hosts gas-fired power plants and is home to 16 special economic zones, 10 of which are dedicated to manufacturing. These zones have high potential for industry-scale energy demand. And third, Batangas is geographically well-positioned. It has multiple seaports capable of handling imported LNG, making it a natural entry point for new fuel sources. Next slide, please. A major development that frames our study is the passage of the Republic Act number 12120, the Philippine Natural Gas Industry Development Act, signed into law by President Bongbong Marcos on January 8, 2025. This landmark legislation promotes the use of natural gas across the country by enabling the conversion of existing facilities and equipment that currently run on fossil fuels. What's particularly important is the condition it sets. Conversions must be technically and financially feasible. That means this law not only encourages the shift, but also recognizes the need for careful assessment and support mechanisms to make it viable. So the findings, can you go to the next slide, please? So the findings are based on several data sources. And first, we conducted a focus group discussion with selected manufacturing locators in August of 2024. We then conducted a survey and received 35 complete responses from manufacturing locators out of a total population of 257 locators in Batangas SEZs. We also drew from earlier GPDP research as well as contributions from our partner institutions such as PEZA and DOE. So to construct our data set, we conducted an online survey between September and December 2024 using the SurveyMonkey platform. So the questionnaire was sent to all locators in 16 special economic zones in Batangas. And out of these, 10 zones focus specifically on manufacturing, which account for about 60% of all firm locators in the province. We use a mixed method sampling framework. From 39 complete responses, we filtered out non-manufacturing firms, leaving us with 35 valid responses for analysis. We also did our analysis by sub-industries, which help us estimate fuel use patterns by finer manufacturing segments to better assess the demand profiles for these firms. Next slide, please. So this table shows the distribution of our survey respondents across the different manufacturing special economic zones in Batangas. So out of the 237 total manufacturing locators, we received 35 complete responses. While this gives us 80% confidence level with margin of error of 11%, I think the coverage was broad enough to reflect the broad locator distribution patterns for the Batangas SEZs and also the manufacturing sub-industries. Next slide, please. So this slide breaks down our respondents according to the type of products they manufacture. So as you can see, the largest segments in both the overall population in our sample are rubber and plastics and fabricated metals, each making up about a quarter of total respondents. Other sectors like electronics, paper products, and electrical equipment were also well represented in the sample, comprising about 9%. While we did get responses from all categories, such as chemical or wood products, the coverage we achieved matches the industrial profile of Batangas SEZs. Next. Now, what we did is to get the consumption profile of these firms, and we then converted this into its natural gas equivalent in million standard cubic feet. And the conversion was thanks to the help of the JERA company and Equinor's LNG calculator. So JERA is the one who's responsible for the conversions, if you want to ask them. Don't ask me, ask this handsome guys over here. Okay? So we then estimated fuel consumption at the SEZ level using several steps. So we identified the product mix in each of the SEZs. Say how many fabricated metal or rubber and plastic firms there are in the SEZs. We then applied the average fuel consumption per product type to non-respondents. So for a conservative estimate, we also computed consumption using the lowest values reported per product type. And for the high-end estimate, we used the maximum reported values. Okay, so to project future demand to the year 2050, we used our survey, information from our survey. In our survey, firms were asked, how much do you expect your volume purchase of each type of fuel to change by 2050? Okay. And then from these responses, we developed 3 scenarios. We have a low estimate, which uses the lower bound of the projected increases, and upper bound for the decreases. This is like a conservative outlook. Then we have the high estimate, which does the reverse. We use the upper bound for increases and lower bound for the decreases to reflect a more optimistic scenario. And the average estimate is simply the midpoint between them. Okay, so that's how we did it. Next slide, please. Next slide. Okay. So these are the results. This chart over here shows the estimated fuel consumption by special economic zone, expressed in MMSCF, or million standard cubic feet. So in 2023, in our survey, the total average fuel use across all zones reached about 477.58 MMSCF. And in here, 2 zones stand out significantly. Lima Technology Center, which accounts for about 41% of total fuel consumption, and First Philippine Industrial Park, which contributes 22%. So together, these 2 zones represent nearly 2/3 of all fuel use among Batangas SEZs, making them strong candidates for natural gas conversion and targeted energy planning. Other zones with notable consumption include First Philippine Industrial Park 2, LISP4, and LISP3, each of them contributing about 10 to 11%. Next slide, please. So, this table gives a more detailed fuel use information by SEZ, which is further broken down by fuel type. So, Lima Technology Center and First Philippine Industrial Park lead in overall consumption, and LPG dominates their fuel mix. Lima consumes an average of 164 MMSCF equivalent, and FPIP about 71 mmSCF in LPG alone. Diesel also remains widely used across economic zones, but at lower volumes. So propane and biodiesel appear in smaller quantities, while gasoline is used minimally. We also included minimum and maximum bounds based on our estimation approach. For instance, the maximum estimated fuel use for Lima could reach 987 mmSCF, while that for FPIP could reach 600 mmSCF. Now, wala pa. It's also noteworthy that FPIP2 and LISP4 rank 3rd and 4th in this table. Even if their locator counts, the number of firms inside these economic zones is lower than LISP3. This is because locators in these special economic zones are manufacturing products that are more fuel intensive, such as rubber and plastics, as well as fabricated metal products. Next. So this slide shows fuel use broken down by the type of products being used. So 3 sectors dominate: rubber and plastic products, fabricated metal products, and motor vehicles and trailers. Together, they account for about 90% of total fuel consumption across Batangas SEZs. And this is important because these sectors involve high heat, energy-intensive processes such as molding, welding, and metal treatment, which are making them likely to benefit from switching to natural gas. Next. Now, this table also shows the same information, but now it's broken down by product types and fuel types. And so those who are producing rubber and plastic, fabricated metals, and motor vehicles, they rely heavily on LPG and diesel. So rubber and plastic locators use an average of 155.9 mmSCF in LPG, while fabricated metal firms consume 76.2 mmSCF in diesel. Motor vehicle manufacturers, although they are few in number, shows high average LPG use as well, around 128 mmSCF. But when we sort of calculated the maximum values for this, especially for rubber and fabricated metal products, they could exceed 1,000 mmSCF. And this has high potential for natural gas substitution. Next, please. Okay, so this chart, so that's fuel use. That will shift to power consumption. And this chart shows power consumption across the different SEZs, expressed in natural gas equivalent, after converting from megawatt hours. So total electricity use across all SEZs amounted to about 10,000 mmSCF in natural gas equivalent. And as before, Lima Technology Center, FPIP, and LISP3 accounted for the bulk of that. Next, please. This slide shows how electricity use varies by different types of products being manufactured. Again, as with fuel use, fabricated metal products and plastic and rubber products are the ones that are dominating. So fabricated metal products over 72% of the total. Okay, so let's now put our numbers in a national context. Let's juxtapose it to current consumption of natural gas in the whole country. So in terms of fuel consumption, the average of Batangas SEZs is, like we said, 477 mmSCF in natural gas equivalent, which is 70% of the Philippines' total industrial natural gas use in the peak year in 2016. So in 2016, we have 2,782 mmSCF for industrial use. And our computation for Batangas is about 477 or 17% of that. So for power, Batangas SEZs consume about 10,000 mmSCF, like we said. And this accounts for about 9% of total power-related gas consumption in 2024. So therefore, Batangas SEZs are already major energy users by national standards. And so when we target them for LNG conversion or infrastructure development, it can yield significant economic impacts. Next. This slide shows the contribution of the top special economic zones and product types to natural gas consumption. Lima Technology Center, if all its fuel and electricity consumption were to be converted to natural gas, this would be equivalent to about 7% of the country's peak industrial gas use and 3% of power-related consumption. Also, FPIP is not far behind. When we look by industry, fabricated metal products, converted natural gas potential is equivalent to 6% of peak to both industrial and power consumption. And this shows that SEZs and these sub-industries are logical entry points for LNG infrastructure. Next, please. So let's go to the demand projections. This table presents projected LNG demand by 2050. Based on the question we asked, how do you expect your energy use to change to 2050? Now, applying those answers, we found that for rubber and plastic products, they are expected to lead demand in natural gas with a projected 44% increase, reaching an estimated 233 MMSCF. Fabricated metal products follow at 162 MMSCF. Now, if we look at this table, motor vehicles and trailers show the highest per locator consumption, but 55% decline in demand because probably of anticipated shifts in fuel mix or production scale. So sectors with growing demand and scalable consumption, meaning rubber, plastics, and metals, together could account for over 80% of projected LNG demand by 2050. Next slide, please. Next slide. Now, our survey also looked at barriers to adopting natural gas use. The biggest hurdle are upfront investment costs, which is flagged by 71% of firms. This is followed by concerns over ongoing maintenance expense and supply reliability. So beyond cost, there's also knowledge gap. 61% of firms cite lack of understanding about LNG. And there are also technical and logistical issues like infrastructure, training, and access. Firms also express uncertainty about actual cost savings, and they also mentioned health, safety, and environmental risk. But I guess the most telling of this is that 1/3 of our respondents don't perceive clear benefits in switching to natural gas. Next, please. Now, our survey also shows how much firms are willing to invest to make that switch to natural gas. And what we found is that 54% of companies are only willing to invest less than 2.5 million pesos. 20% of our respondents are unsure or don't see the investment as applicable to their operations. And only a small fraction are prepared to commit a higher amount. Only 14% commit 5 to 10 million to invest for natural gas switching, and 6% for 10 to 20 million. Next slide, please. Okay, so despite the cost and technical concerns, there's strong environmental motivation behind switching to natural gas use. 71% of our respondents said they were factoring in greenhouse gas emissions into their investments decision. 66% are willing to adopt natural gas, specifically to reduce carbon dioxide emissions. So this creates an opportunity if LNG can be clearly framed as both an environmental and economic improvement, there is a receptive audience. Okay, to summarize our findings, natural gas consumption in Batangas SEZs is already substantial. So compared to national totals, this makes the Batangas region a natural starting point for broader LNG adoption. Not region, but the province itself. So In terms of size, Lima Technology Center and FPIP are the biggest energy consumers in both fuel and power. And they are positioned as high potential targets for LNG investments. Now, from a sectoral perspective, fabricated metal and rubber and plastic products are strongest candidates for conversion. They use the most energy, and they make up 43% of all Batangas locators, and they are the most likely to increase fuel use by 2050. And these industries also operate high heat equipment, making them both amenable for switching to LNG. Next. It's also worth noting that SEZs attracting more transport equipment like FPIP2 and LISP4 could become major fuel consumers in the future. Motor vehicles have high energy requirement and their growth could reshape the demand projections. LPG is the most used fuel among SEZs, and then followed by diesel. So most other fuel types show minimal to no reported usage. Next. Okay. So our study also highlights that shifting to natural gas requires substantial modifications or entirely new equipment for most firms. So current systems are generally not compatible with LNG. Respondents cite high upfront costs, high maintenance expenses as the biggest barriers, and the reliability of supply is also a major concern. Most of the firms are only prepared to make very small investments, typically under 2.5 million, which limits large-scale transitions without support. And most are not ready to integrate regasification plants on site. Next. But despite the technical barriers that these firms face, many of them have relatively low threshold for justifying a switch to natural gas. So the firms, when we ask them, they only require about 1 to 10% decrease in operating expenses for them to switch to natural gas. Now this suggests to us that it only requires a modest economic trigger to unlock this broader adoption. And the study leads to key recommendations for the Department of Energy and for potential investors. First, we need to direct the LNG transition efforts towards high-impact locations like Lima Technology Center, FPIP, and also to prioritize high energy-intensive sectors like fabricated metal and rubber and plastics. But we also must keep an eye on transport equipment, especially in zones like FPIP2 and LISP4. Because although they are small in number today, they have the capacity to drive significant demand in the future. We also should focus on fuel-intensive industries as they are more technically ready for LNG conversion. Their equipment and infrastructure is already suited for high heat processes. Next. We also recommend the following policies to overcome hesitancy towards shifting to natural gas. First, conduct information and education campaigns that highlights not just cost savings, but also environmental benefits, especially reduced carbon dioxide emissions. And we must offer flexible and phased implementation plans for LNG conversion. And we should start piloting this in SEZs with the highest fuel and power use. And that's why Batangas SEZs are the perfect test case for natural gas conversion. Next. So we also recommend for policymakers to support the development of a domestic LNG supply chain from import terminals to last mile delivery to improve reliability and give firms the confidence to transition to natural gas. And finally, and for economists this is potentially the most controversial, is to offer a mix of fiscal and non-fiscal incentives. This includes tax breaks, grants, streamlined permitting, or technical assistance. The only controversial here for economists is tax breaks and grants. The rest, okay lang. Okay? So while these support mechanisms are in place, we can lower adoption barriers and make LNG a more competitive and accessible energy option for industrial users if these policies are adopted. Yes. Okay, so in behalf of the GPDP research team, Ma'am Baybelin, and our partners, I thank you for your interest and attention. We invite you to read the full paper, and we would be happy to answer any questions if there are any. And yeah, we look forward to any questions if there are some.